It's February 9, 1963 to be exact, and airplane number 1 is ready for its first flight at Boeing's Renton Airport in Washington State. From today's date, that left less than 11 months to meet the December certification deadline specified by the two launch customers, United and Eastern Airlines. Heading up the test pilot team was Lew Wallach, Jr. Co-pilot Dick Loesch and flight engineer Marvin Schellenberger stood by while the logbook was ceremoniously signed by Captain Wallach. Meanwhile, final preparations are made for the flight that will ultimately end in the 727 gaining full FAA certification. The last pre-flight check is to exercise the hydraulic-powered flight controls one final time to confirm their proper operation. With all three engines started, the ground crew clears the last of the support equipment away, and Captain Wallach advances the thrust levers and taxis out. The weather was cooperating too. It was an unseasonably clear day with light winds from the north. This was essential, since all departures had to be on the north runway, out over the lake and away from populated areas, just in case. Finally, all eyes focus on the 727 as it starts its takeoff roll. Weighing in at about 130,000 pounds, the acceleration is brisk, and the ground run is barely over 3,000 feet. Remarkable for a jet airliner. Still, the unexpected happens, though, when the center engine surges just after liftoff. The crew reduces power on it somewhat, and the vibration mysteriously terminates. Yet another problem was discovered when the wing leading edge flaps could not be retracted. Apparently, the hydraulic actuators for them were too small for the air loads and would have to be redesigned. Nevertheless, 2 hours and 6 minutes were spent evaluating the handling of the 727, and for this, it got an enthusiastic thumbs up from the crew. The first landing of the prototype was at a different airport, Payne Field in Everett, Washington. Approach speed was 110 knots, confirmed earlier in the flight by stalling the airplane, so they knew exactly just how slow it could fly. The flaps were also extended to their maximum value of 40 degrees. After touchdown, Captain Wallach applied moderate braking, while the engines were only placed in idle reverse thrust. Amazingly, even on their first landing, the crew was able to stop the 727 in only 2,000 feet of ground roll. The next day at Everett, before the real work began, ground tests were completed on the 8 tons of onboard equipment which were required for the flight tests. Low-speed flight was the first area examined on the next few tests. 750 individual perimeters were recorded in flight for later analysis by ground-based computers. 16 hours and 21 minutes were spent testing the aircraft at slow speed. This included numerous full stalls. With the aircraft stabilized at its minimum flying speed, the pilot would apply consistent back pressure, forcing the nose to an even higher angle of attack. Prior to stall, the aircraft would buffet and the nose would pitch down itself, effectively recovering from the stall on its own. The airplane could quickly be returned to level flight. With the slow speed testing complete, the 727 entered the high-speed phase of testing, specifically how turbulence might affect high-speed flight. The right-hand elevator had a small vane attached to it to induce flutter to the tail. Flutter is a potentially destructive force at high speed, so it was imperative to see how well the 727 naturally dampened out these vibrations. The right-hand wingtip had a similar vane attached also, but the wing itself moved only very slightly. The aircraft was also flown in a dive to airspeeds of 460 knots and Mach 0.96, clearing it with regard to flutter and high-speed flight. The wing was also a radical new design and received much testing. The tried-and-true method of attaching small tufts of yarn to the wing made it possible to visually see the airflow. With the spoilers up, the airflow took on a different look than before, as evidenced by the tufts behind the spoiler. Rolling maneuvers were initiated to record photographically the effects on the airflow. The arrow points to the area of tufts that delineate the shock wave caused by the wing as it approaches the speed of sound. Sections of the lower wing were tufted also to study airflow around the flap tracks. Other sections of the aircraft of interest to the engineers were also tufted and photographed at varying airspeeds. In all these cases, the airflow exhibited by the tuft patterns was smooth and streamlined. This proved the 727 had good airflow characteristics. Back at the airport, testing continued on takeoffs and landings. A normal takeoff, weighing 145,000 pounds, yielded this departure. For the high rotation test, the test pilot would accelerate to liftoff speed and pull back harder than normal on the stick. The weight was also 145,000 pounds for comparison purposes. This test was to prove that the aircraft could still continue flying after such an abusive pilot input was made. The over-rotation test was even more dramatic. The test pilot held the stick full up from the start of the takeoff roll. This causes the nose to lift prematurely and the tail skid to strike the runway surface. Again, it's all to prove the 727 can definitely continue flying if it happens for real. The refused takeoff tests were conducted at Edwards Air Force Base in California. These tests were made at the full range of permissible takeoff weights for the 727 and every possible flap setting. The test pilots accelerated the aircraft normally to its liftoff speed, today calculated at 124 knots. At that point, instead of lifting off, the throttles were closed and the wheel brakes were selected to maximum. The engine thrust reversers were not allowed to be used. The distance it would take to stop the aircraft would be recorded and used later by the airlines. Maximum effort landings using brakes and thrust reversers were also demonstrated. In this landing, the 727 weighed 133,000 pounds. Amazingly, the ground roll was a mere 1,700 feet of runway. Landings were also made on wet runways too, to test the effectiveness of the new anti-skid system developed for the wheel brakes. Even though the brakes were applied to maximum by the pilot, and even though the runway was wet, no skidding occurred. These tests confirmed the effectiveness of anti-skid on wet runways and exemplified the typical 500-foot difference between dry and wet runway ground roll distances. The 727 was flown to Great Falls, Montana for crosswind landing tests. This part of the country notoriously had strong, steady winds, which proved perfect for the test series. The gross weight for this landing was 132,000 pounds at a flap setting of 30 degrees. These tests eventually certified the 727 for landings in direct crosswinds of up to 30 knots.